Okay.
All right, so hello everyone and welcome. My name is Greg Davis. I'm a senior solutions architect with AWS. I currently work on the certification team to help develop the AWS certification exams. I'm also a member of our internal serverless technical community. I've been with AWS for over 2 years now. I live in Austin, Texas, or northwest of Austin, Texas. I've been a solutions architect, a developer, and a database engineer for over about the last 13 years or so. And prior to that, I worked in the financial industry for about 12 years as a stockbroker and a managing principal. Also dabbled on the technology side of the financial industry for a large portion of those 12 years. Most of my knowledge has been acquired over probably thousands of hours of online and instructor-led training courses. And I do currently hold 10 AWS certifications. Fingers crossed, I'll have the last machine learning certification by the end of 2021. That's a goal of mine. It's probably one of the more difficult ones, ranks right up there with advanced networking. Um, Building serverless solutions, though, is definitely my passion. And today I'm excited to talk to you about Lambda. We'll give an introduction to Lambda through a brief presentation, and then I will jump into a live demo. And let's hope that goes well. So I'm going to go off for camera right now, and we will begin the presentation. All right, so before we dive into Lambda, let's talk a bit about what serverless is. What does it mean when we say serverless? There are tenets that define serverless. These tenets are more operational models than anything. So with serverless, there's no infrastructure or servers to provision or manage. Serverless solutions should automatically scale based on the consumption or the load. With serverless, you should only pay based on the value provided, and there shouldn't be any cost for any of the idle time where your workload sits idle. Serverless should also have built-in availability and fault tolerance. So, in other words, serverless means to remove the undifferentiated heavy lifting of managing infrastructure. You may have heard lots of others refer to that term, undifferentiated heavy lifting. That just means to focus on the things that are important to you, that make a difference to you, and to let us manage the undifferentiated heavy lifting. It's an important distinction for customers because it allows them to focus on just building their applications rather than managing and scaling the infrastructure to support those applications. So now about Lambda, how does Lambda fit into serverless? So let's look a bit more into it. Lambda is considered a function as a service, similar to the terms you may have heard, platform as a service or infrastructure as a service. Lambda has coined a function as a service. It allows you to run code without provisioning or managing servers. You only pay for the compute time and the memory that your function consumes. Lambda automatically runs your code with high availability across multiple availability zones within the same region. And the functions scale with usage, which we'll talk about a bit more in the next slide. So as you can see, Lambda meets all of the tenets that we talked about of the serverless operational model. The first time you invoke a Lambda function, it creates an instance of the function to process the incoming event. And we'll talk about events more in just a bit. If you invoke the function again while the first event is being processed, Lambda initializes another instance and the function processes the two events at the same time or concurrently. As more events come in, Lambda continues to load balance the events across the available instances, and it auto scales to create new instances as needed. And then, of course, when the load decreases or the number of requests goes down, Lambda stops the unused instances to free up the scaling capacity to use for other functions. Regarding error handling, specifically for asynchronous invocations, Lambda automatically retries on error and delays the time between retries. It's also called exponential backoff. And a dead letter queue can be assigned to the function to capture events that weren't successfully processed. Each Lambda function is executed within an isolated environment to help increase security. And as I mentioned before, you do not need to maintain or patch an operating system with Lambda. AWS does manage that infrastructure for you. This slide illustrates the different compute options offered by AWS. For example, if you want full control over a virtual server, along with control over the operating system or maybe the underlying storage and networking, EC2 is probably going to be a good choice for you. If you want to run containers, you can choose ECS or Fargate. And AWS Fargate manages the underlying infrastructure while you manage the container configuration. But as we mentioned before, if you only want to focus on your application code and let AWS manage all of the underlying infrastructure, then Lambda may be a good compute offering for you. This is the spectrum of shared responsibility that you have over your options for compute within AWS. For example, starting at the bottom, a less opinionated choice, meaning opinionated in that we control things versus you control things. Less opinionated is you controlling it. More opinionated is AWS controlling more things. EC2 sits at the bottom down there. It allows you to build and run things. You manage all of it, including the integrations, any scaling, security config, provisioning, patching, etc. Um, and in addition to your code, so all of that you manage yourself. And then compared to the top, the more opinionated offering is Lambda, where all you need to worry about is your application code. So let's dive a little bit deeper into the anatomy of a Lambda function. So first off, Lambda does support several different programming languages, and you see a few listed here. It supports Node.js and Python and Java. The top two most popular are, of course, going to be Node.js and Python. Um, on the left side, then it shows event sources that are integrated with a Lambda function. So for example, you could just execute a Lambda function by itself if it contained all of the necessary code that it needed to run a particular workload. But more often, you see Lambda functions used as a way to process events that come in from other services. For example, you might have a change in data state on a DynamoDB table, and DynamoDB streams is configured to route changes to that DynamoDB table to a Lambda function for further processing. There may be an object that's uploaded to S3, and that S3 object, that event of the act of creating that S3 object can be sent to a Lambda function for further processing. There may be requests to an API endpoint that come in, and then that API endpoint is integrated with a Lambda function to process the incoming API request. It could also be just other changes to resources within your AWS environment that are tracked through EventBridge, and EventBridge can then send those events to an integrated Lambda function for processing. On the back end of that, of course, Lambda can then integrate with other services as well. For example, after performing some sort of processing, it could write to a DynamoDB table or an RDS instance. It maybe could write a smaller version of a S3 object or image file into a different bucket, maybe for thumbnail creation, things like that. Or it can call external HTTP endpoints if you needed to make a call after the processing is complete for notification of some kind. The anatomy, again, of the Lambda function in a bit more detail includes a handler function, an event object, and a context object. If you look at the code in the green box, this represents a very basic Lambda function. It's a Python script. It just converts a string into JSON, and it returns hello world. The handler function is the starting point that is executed first whenever the Lambda function is invoked. And then from that handler function, you could call out to other subfunctions if you needed to perform other processing. The handler receives both an event and a context object. There's different things contained within each one of those. For example, the event object contains event data from the invocation source. So for example, if the invocation is from API Gateway, the event object would include things like the path parameters or method, the HTTP method, headers, request body. If the invocation is from Amazon S3, then it'll contain information about the bucket or the key name or what type of action was taken on the S3 object, like a created object or a delete object. The context object, on the other hand, that what we just talked about was the event object. Now, the context object, that represents information specifically about the Lambda invocation and the configuration itself. So things like the amount of memory that's allocated to the function, a unique request ID that's provided upon each function invocation, the location of the log files that are outputted from the function, and the function name and version, and a method that you're able to use to obtain the remaining time before the function times out. The Lambda console itself offers a lot of functionality. For example, detailed monitoring and different debugging features. At a quick glance, you can view important metrics such as the number of function invocations and error counts, latency, duration, things like that. You can also view the logs from the function for debugging purposes. And I'll actually dive into a demo here in a bit, and I'll show you some of the screens within Lambda. All right, so let's talk about the execution models a bit. So there's three different execution models that you can use to invoke a Lambda function. The first is synchronous or push based. Um, an API request, for example, would be an example of a synchronous or push-based execution model. So the API might integrate with Lambda function. The function then is expected to process that request immediately and then return a response. So think of websites and things that might integrate through an API to Lambda. It needs potentially a response back right away to the original caller. Next, let's look at asynchronous execution. So let's say you upload an object to S3, as I mentioned before. A message is then published from that S3 event to Lambda. Lambda then takes its time to process that event, and it doesn't necessarily call back to S3 to let it know it's done. Or you may be publishing a message to an SNS topic, and then Lambda subscribe to that SNS topic to perform some sort of additional processing on it. It's not going to call back to SNS in that case to provide a response. It's an invocation of the function that occurs asynchronously. And then finally, there's a stream or pull-based execution model. This is where the Lambda service itself, there's a difference between the Lambda service and the Lambda function. The service is just a general thing on our side that we control that manages the functions and all of the backend infrastructure for Lambda. The service creates a poller, and this poller reads messages in batches from the streaming service, such as DynamoDB streams or Kinesis or even an SQSQ. Lambda service, for example, polls the SQSQ periodically to retrieve messages in batch for the function to process. So as you can see, depending on your serverless architecture, there are three different ways in which you can process events in Lambda. A Lambda function has two different permission models. A resource-based policy that controls which services can invoke the Lambda function. And then there's an execution role assigned to the Lambda function that controls which actions or which services the function can take or access. So in other words, from the function's perspective, who can trigger me and what can I do? That's what resource-based policies and execution roles are for when it comes to Lambda. And as we talked about before, an important part of serverless is to only pay for what you use. That's exactly what Lambda offers. You only build in 1 millisecond increments based on the function duration. There's no commitments for usage. You do not pay if your function is not invoked. And as of October 2021, so this month, as an example, if you allocated 512 megabytes of memory to your function, executed it 3 million times in 1 month, and ran it for just 1 second each time, that's the function duration, your cost would be $18.74. So it's got a pretty good pricing structure, really fine grained down to 1 millisecond increments. There's many different use cases for Lambda 2. Here's a few. You can look at these. Basically, it's used for things like backend processing on websites, for IoT solutions, for real-time or batch data processing, whenever you may be building an Alexa skill. And then, of course, for managing AWS infrastructure, you can make AWS API calls through a Lambda function as well for that purpose. Regarding customer use cases, the Seattle Times, for example, uses AWS Lambda to resize images for viewing on lots of different devices. So your mobile phones, your desktops, your tablets. Logalytics processes billions of data points in near real time and uses Lambda to process historical and live data that they store in S3 or stream from Kinesis. And then Zillow, the real estate app, they use Lambda and Kinesis to track a subset of mobile metrics in real time. And then with Kinesis and Lambda, AWS and our architects were able to develop and deploy a pretty cost-effective solution in under 2 weeks. Here's some examples of customers using Lambda at scale. We mentioned that as one of the tenets of the serverless operational model, that serverless should be able to scale on its own. FINRA, for example, validates 500 billion stock trades on a daily basis with Lambda. Fannie Mae was able to scale up to 20,000 concurrent executions during the load test. And remember, concurrent executions, that's a function coming in and being processed at the same time. So it's spinning up a number of different instances to be able to manage those concurrent requests. It could get complicated sometimes to try to decide when to use Lambda versus when to use other compute offerings. So we came up with a fairly rough guideline for selecting the compute platform based on your workload. Basically, if the workload does not require more than 10 gigabytes of memory, that's the current Lambda limit, and the workload can be executed in under 15 minutes, Lambda may be a good choice for you. And I would recommend Lambda in that case. Otherwise, consider maybe using containers. And with containers, you can use Amazon EKS, the Elastic Kubernetes Service, if you require more portability or an open source solution. Or you could also use Amazon ECS, the Elastic Container Service, or Fargate if you want to use more AWS native solutions. So again, that's if under 10 gigs of memory or under 15 minutes, Lambda's probably a best choice. All right, so on to some best practices for Lambda. If you are thinking of developing with Lambda, these are some things to consider. There's a ton more out there available online. I highly recommend that you do a web search for Lambda best practices and just check some of the available content out there. The smaller the function code, the faster it is to deploy and launch the function instance. So you'll be able to save some time there. It might help to reduce cost, the more efficient and small your code is, obviously. You can use the local temporary storage for faster processing of small files rather than reaching out, say, to S3 or using an EFS. If you have the ability, consider using either in-memory or the local temp directory for processing of things. And then remember, of course, when Lambda service creates new instances of the function, the instance remains available for a period of time to process those subsequent or requests that come in after another one was just processed. That same instance remains available for a short period of time to continue processing more requests. This allows you to cache variables or use data on local temporary storage between the different invocations that may occur on the same function. Another tip is to make sure to output helpful logs, especially during the development phase, output everything. Of course, maybe scale that back during production. And then consider publishing logs that include some metrics that you can track through CloudWatch Logs metric filters. The metric filters could then provide you with an easy way to visualize the important operations and business data. All right, so now I'm going to stop sharing this presentation and I'll move on to the demo portion where I'm going to attempt a live demo of a Lambda function that's integrated with API. So let me pause here and just give me a moment while I set up my side for the demo. Okay, let's share this screen now. Say a prayer to the demo gods that this works. All right, you should be able to see the screen now. Okay, so I'm logged into the AWS Management Console. And the first thing I'll do is let's go over to Lambda. So up at the top search bar, I'll just type in the first bits of Lambda. There it is. Click on it. And I'm in the Ohio region. Doesn't necessarily matter which region you're in. You can choose any available regions to you. But let's start off with just simply creating a basic function. So I'll click Create Function. I'll use author from scratch just to start off with a simple Hello World example. I'll give my function a name. Let's call it Demo. And I'll just choose the Node.js 14x runtime. If you drop this down, you'll notice that there are several supported runtimes available. Let's just keep it set to the default, Node.js 14. And you do have the choice of architecture now. The ARM64, that's the new Graviton 2 processors from Amazon, which I highly recommend you checking it out. It could provide some substantial cost savings as well as performance improvement, which might as well go ahead and try it now. All right, so I'll leave everything else as default and I'll click Create Function. Give it a few seconds to spin up, and then I'll be presented with just a simple hello world example of a Lambda function. And here we go. Okay, so just to sort of break this down a bit, this is that handler that I'd mentioned. This is the first function that needs to be placed inside your code. That's what's called first when the function is invoked. And then all of this is doing is simply returning a response. You can see the final return response, and it's just converting a string to JSON format, and the string is just hello from Lambda. So that's easy enough. What I have available to me here in this console, lots of different things, the ability to test, to monitor, to configure, set up versions and aliases. Let's just look at a few of these things. So for example, under test, I'm going to configure a test event. And if you recall, during the presentation, an event is something that occurs that invokes or triggers a Lambda function. And an event is literally just data in JSON form that is sent to the Lambda function that the Lambda function can interpret and use as part of its processing within code. The default event is just a test event. It's just a key value pair of a couple of keys here. There's also lots of different templates, sample templates that you can choose from that show what the event may look like if it comes from other AWS services. So for example, if it comes from an API endpoint, you can choose API AWS proxy. And this is an example of what the event may look like if you receive it from API gateway. If we choose, let's say S3, let's just do an S3 put. This is simulating creating an object in S3. This is an example of what the event may look like from Amazon S3. But I'll go back to just a blank event, that hello world right there. And I'm just going to put in test and click create. Okay, so now that I have a test event to test out this Lambda function, to manually invoke it, I'm going to just press the test button. So I just press the test button. It shows the test event that I used and the status code response, which is just hello from Lambda. So that worked out perfectly. If I go over to monitor, I can then click to view logs in CloudWatch. I can also view most recent logs directly from the console here, but let me show you what it looks like in CloudWatch logs. A log group is automatically created when you first invoke the Lambda function. This log group is named after the Lambda function itself. So you can see up at the top, it's AWS Lambda demo. And the first log stream in that group, this denotes the invocation that I just did when I clicked that test button. So if I click into this log stream, and let's expand all of the outputted log events from that function, you can see there's just basic things. This is stuff that just comes along by default when the Lambda function is invoked. I'm not outputting anything custom in the log. I can go back to my code and change that. Let's just add a console.log, and I'm going to log whatever the event is, which is an object that I received when I invoke this function. So I'm just going to write out to the log the event. So I just made a change to my code. I'll click deploy. And now when I test, it shouldn't have broken anything because all I'm doing is outputting to a log file. So it looks good. Still got a status 200 back, no errors there. And let's go back to CloudWatch, go back to my log group. And now I see another log stream. This represents that second invocation that I just made with that additional change to the code. So I should see an additional log in here. And I sure do. This second one right here, this includes the event that it received when I invoked that function. And if you recall, that is the JSON of that test event that I created, just the simple, the sample hello world test event that comes along with the Lambda. All right, so now let's do something a bit different. Let's associate an API endpoint with this Lambda function and invoke it from API Gateway. So to do that, I will go over to API Gateway. I'm going to create it through the console here just so you can see there's two different ways to do it. I could also create it directly from the Lambda console, but I'm going to go over to API Gateway first and do it here, and then I'll show you how to integrate the two together back in Lambda. So from API Gateway, I'll choose to create just a basic HTTP API. There's other APIs available, including REST APIs, which offer a bit more functionality. Soon there may be additional feature parity between both HTTP and REST APIs. HTTP APIs are a little bit more cost effective than REST APIs, but of course REST APIs currently provide much more in the way of features. But let's just build a basic HTTP API so that we can use this as the front end to invoke our Lambda function. I'm not going to add any integrations here. I'll do that through the Lambda console, which I'll show in just a bit. And for my API name, again, I'm just going to put demo. Click next. I don't necessarily want to add any resources, or paths. Let's click next, and I'll just accept the default stage, next, and create. So within a couple clicks, I just successfully created an HTTP API through API Gateway. And now let me go back over to Lambda. I'll click Add Trigger up here in the function overview. And then I'll select that it's going to be an API Gateway as the service that's invoking this function. And then I'll choose my demo API that I just created. Default deployment stage. And I'll just make it open right now. You probably won't want to do this in real life. You'll want to have some sort of authorizer to secure this API just a bit more, but I'll just choose open. And I'm going to tear this down shortly after this demo. So if you're watching this through recording, the endpoint that I'm about to hit through my browser may not be available. Let's add this. All right. So now we have this endpoint that if I executed this API endpoint, it's going to invoke the Lambda function and provide a response. So let's try that out now. And it just executed the function, and we can see in my browser, hello from Lambda. I'm going to paste this endpoint into Chime. And Tim and Ed, if you two don't mind, grab that link and just navigate to the browser and just hit that link a few times on your side. I'm just hitting it a few times on my side. All you should see is just hello from Lambda. That's all the function's doing currently. While you guys are hitting it on your side, I just did it a few times on mine. I'm going to go back to the metrics section under monitor to check out what we got. Takes a bit for the metrics to pull up the first time. Let's narrow that down a bit, just the last hour. Ed and Tim, is the API endpoint working for y'all? Yep, okay. Thanks for the response. You got the hello from Lambda, Tim. Good, good. Ed's working for you. Awesome. Okay. All right. So what you'll notice though is there are, multiple invocations that are occurring, over the span of however long we were just doing that. But there's only really, one instance. It's just, always just one concurrent running at the same time because it executes so fast. If we go back to look at the CloudWatch logs, you'll notice that the duration, I'll just look at them from here. Check out the duration, 34 milliseconds. It's extremely fast. So it's executing each one of ours in the blink of an eye, and it's reusing that Lambda function instance for each one. We aren't enough people to hit this thing fast enough to be able to cause it to create another instance to run concurrently. So it seems like it's processing ours subsequently and within the same instance. But that's an example of Lambda. I just showed you a basic Lambda function within code. We looked at the way to see logs. We made a slight modification to the code so you can see its effect that it has within the log to be able to output stuff. We associated the Lambda function with an HTTP API endpoint, and then we all took turns hitting that endpoint and producing some invocations of that Lambda function. That concludes my demo. So Tim or Ed, if you guys had any questions, I'd love to hear them now. And Tim, it's up to you if you want to stop the recording now or also include the questions. And y'all can feel free to come off mute if you'd like.
Greg, first of all, thank you very much for the demo. I really appreciate it. I don't know much about Lambda because I've only just finished my cloud practitioner certification, so I'm pretty much at the bottom end of my learning process. If you don't mind, I've just got a couple of fairly generic questions.
Sure.
You mentioned several companies earlier on who are using Lambda, and just out of curiosity, when those companies like Seattle Times or Zillow, when they started using Lambda, what was the benefit that those companies, those customers saw from using Lambda to before they were using it? Have you got some performance metrics, as in cost or efficiency, anything like that?
Sure, I don't have specific numbers that I can talk about, but the clear reason these customers choose to switch to a serverless solution, one is primarily cost savings, right? You're not having to pay for idle time, you're not having to pay for the management of that infrastructure, all that goes into operating a set of servers and networks and storage and backups and security and all of that, you're that's all sort of stripped away from you, right? And you're left with just developers that can write code. So the clear reason a lot of people choose serverless is for the obvious benefit of cost savings, and it takes away the things that really don't differentiate those customers from one another. So the Seattle Times, they're going to compete with other news reporting agencies, journalists agencies, that they're not in the business of technology, right? So they're in the business of providing good content to their readers. They're journalists, and they focus on that. So that's what they do. So they're not in the business of selling servers or any kind of technology. So as much as they can obfuscate that away from their responsibility, the better. So cost savings is clear. The ease of maintenance of the solution is clear. Um, the speed in which they can scale globally is a huge benefit to these customers as well. I mean, imagine what it would take to scale when you're having to build out all of the infrastructure yourself, right? So if you've got to build the servers and the networking and the backups and the talks, everything to talk between one another, that gets complicated pretty quickly. And with serverless, our customers are able to see an immediate ability, that agility to just quickly test or develop or spin up new things or go global. All of those are huge reasons why our customers are choosing serverless.
Got it. So they can basically save on the IT staff. They don't have to they don't have to hire the IT staff to then run those EC2 instances for them.
That's right.
Roger. Okay, that makes perfect sense. When we just did the demo, we noticed that the delay was something like, it was extremely quick, like 35 milliseconds. Are there occasions where calling up Lambda might take a bit longer because the program is much more complex? Are there any use cases where that would be the case?
Sure. It's all depending on what workload the function is performing, right? So if you have a function that is extremely small, like the one we demoed, it's going to provision and execute very fast in the blink of an eye. You won't really, it's milliseconds as we showed. But if you have something, for example, that's querying an object in S3 and it's performing some resize or some processing on that object in S3. Maybe it's as a spreadsheet, and it's got to look through all the records in the spreadsheet, or it's it's an image that it has to redact some things in or something. Then obviously those types of things might be more intense in its processing, and you can start to take from milliseconds to maybe seconds to process. Most workloads in Lambda are done extremely fast, and that's why we've been pretty comfortable setting our maximum timeout to 15 minutes right now. A huge majority of the workloads run under 15 minutes and are worthy of Lambda. Anything that is much more processes intensive than that, then you'll have to look at some other solutions like either EC2 or containers.
Roger. And would the 15-minute mark be pretty much the point where it may not be cost effective to use Lambda, or do you think it would still be cost effective to use Lambda for even slightly longer periods?
Well, that's a hard limit right now. So if your workload takes longer than 15 minutes, and it's always going to take longer than 15 minutes to execute, Lambda is not going to be an option, because that's just a hard limit that's set right now. You do have
Right.
options to either spin off additional Lambda functions or to use AWS step functions to perform things in more of an orchestrated workflow. And those are ways in which some people have broken up a longer process that may take over that 15-minute interval. They're able to architect a process that breaks that up into chunks. Maybe stores its work within a queue someplace or in a DynamoDB table, and then it just sort of keeps chunking away at the work that it needs to do. And if it doesn't happen to complete within that 15-minute mark, then it may spin down, and then it'll kick off another function, or the step functions will kick off another step to do more work. So there are ways around that 15-minute timeout. But if it's something that can't be interrupted, and it does take longer than 15 minutes in total to process, then look at EC2 or containers as an option.
Yeah, that makes sense. Have you ever come across a customer or a use case where the customer said, or where the customers tried Lambda and they've realized, hang on, this is not what we need. We're going to go back to the previous service that we've used.
I've not come across that. It's usual that developers have a pretty good idea before they start developing with Lambda. They understand what its abilities are. They understand the 10 gigabyte memory maximum that includes up to six vCPUs. They understand the 15-minute timeout. So they're already aware of what those limitations are, and they can build accordingly. So I don't know of instances where they've started down a serverless path and they've decided that that's not for them. Let's go server. I've seen several instances where the opposite is true. Where they've gone down the traditional path of building with servers and having applications run on servers that are running continuously, and then decide, well, this might be better off served with a serverless solution, and they switch to serverless. But I haven't seen too many instances, or really none in my case. I'm sure it's happened before, but I haven't experienced that where they've switched from serverless after intending to go to serverless for particular reasons, and then switched back to a server solution for some reason.
Okay, cool. So the normal process has always been they've used EC2 instances and then they've evolved from there.
That's usually the evolution, right? I mean, if you think about the evolution of compute, we've gone from physical servers in server rooms, and where administrators have to maintain everything, and the provisioning of those could take months to complete, to virtual servers running on the physical servers, and the ability for admins to spin up virtual servers relatively quickly and have a bit more flexibility and the speed and availability of those virtual servers for different workloads, to containers, which completely obfuscates both the physical server and the virtual server from it. Now you just have everything you need for the container containerized within its application, and you don't have to worry about the OS or the hardware that it's running on, really. To now functions as a service with things like Lambda, to where all the stuff that I just mentioned is completely obfuscated from you, and you're just focusing on the application code itself. So yeah, it's that natural evolution that we've seen, going from physical servers to virtual to containers to now functions.
Got it. Yeah, thank you.
Chris, let me ask while I have a moment here. I don't know if you saw my question in the chat. When you had deployed your hello from Lambda, and I was clicking on refresh, is there an access log like there is in Apache for would record an IP address and browser and the usual things that are in an HTTP d.access.log?
Absolutely, yeah. There's the IP addresses that are sent through API Gateway. I believe that's part of the event. Let's go check out that now. But yeah, there's a lot of things in the API Gateway event that Lambda receives that it can act upon. Let's go look. I believe I was still outputting the event. Yeah, it looks like I was. And here's an example of the event that was received. And you can look at things like the exported for. And there's also.
Yeah, that's me. That's me.
Yeah, there you go.
Okay.
So then the answer is yes.
Yes. Okay, thank you.
You might want to change that after this demo.
Yeah. Yeah, we're still recording. Okay, no problem.
But yeah, notice all these things that are here, right? So the path is present. The method that was used, which is, if we just hit it through a browser, it's doing a default HTTP GET. So it shows us what method was used. If we send any query strings to that endpoint, then it would identify what those query strings are. Like a question test equals whatever. If that was part of the URL, it would identify that. So all of the things that are part of that API request, Lambda has the ability to receive as part of that event, to then make that part of its code when it's processing things. You might have your code might do something different if it's a get request versus a delete or a put request, right?
Right.
And then it may use the query string parameters as part of the values when, say, looking up an ID, looking up a record in a DynamoDB table or something. You might pass along like a unique GUID to look up in a DynamoDB table. So all of that data that's necessary for Lambda to perform its processing are usually there in that API request.
Yeah, that's interesting. It looks like the information is much more granular than you would get, and like I say, like an Apache access or an Apache error log. That's very interesting. I just didn't know where that was. I figured it was captured somewhere. I just didn't know where.
And there's other places too that those types of logs can be recorded if your Lambda function is part of a VPC, then you could, of course, enable VPC flow logs to look at different things. There's access logs within API gateway that you can configure to look at different things, and you could log those to S3, for example. So there's lots of different places where you could potentially enable logging to get more advanced. This is just what Lambda sees as part of that event.
Right. Okay. Thanks. That's very interesting.
Of course. Yeah, thank you for the questions, Ed and Tim. Appreciate that. All right.
No,
so if
thank
there's
you. Thanks for the info.
Absolutely. Yep. So keep learning. Go out to the web and search for AWS Lambda and look on YouTube. There's tons of stuff. Also, I'll direct you to serverless LAN. Let me go there right now. There's a lot of cool things on serverless LAN just regarding AWS serverless services in general. We have a link to all the things that are new regarding serverless. There's blogs that you can learn. There's videos. And the cool thing about this is once you start getting into developing Lambda functions and you want some sample code, go to the patterns section. And the patterns section will actually give you quick snippets of code that you can use to do very common serverless things, like integrating, like we did, where we integrated an HTTP API with a Lambda function, or API gateway going direct to DynamoDB. So there's lots of little serverless patterns out here that you could choose from when you get into that part of your learning phase.
Got it. Thanks.
That's very helpful. You don't have to reinvent the wheel for everything.
For sure. That's the whole point. Yep. Might as well save some work.
Yep.
All right. Well, I appreciate it, guys. Tim, I guess you can stop the recording, and thank you.
I will stop the recording, but I'm going to thank you publicly on this recording before I stop it. I think that was great. I'm sure, I know I learned something, and I'm pretty sure Ed and our audience did too.
Good. Thank you. I appreciate you.